Before beginning the lab, proper lab attire should be worn. Long pants, shirts with sleeves, and closed-toed shoes, goggles are acceptable. Before using the spectrophotometer, cuvettes must be filled up using the solutions from prior completed serial dilutions. Solutions should be put in cuvettes using pipettes, and the meniscus should lie directly at the mark. After filling the cuvettes, it's time to take them to the spectrophotometer. There should be a cuvette filled with blank water, stock solution, and then your other dilutions. First, you take your blank, clean both sides with the Chem wipe, then place the sample inside the machine and close the door. Next, inside the scan program, you must zero the machine so that way you can get accurate readings for the following solvents. The machine is only required to be zeroed once. After that, you may continue repeating the same method for your stock solution and your other dilutions. It is important to pay attention to the computer to record the absorbency of each solvent. It is also important to pay attention to the graph presented on the screen. It is important to scan across all wavelengths when doing spectrophotometry. Scanning across all wavelengths shows which solvents are present and if they're different, and it also shows the maximum absorbance for the particular solvent you are working with. The wavelength in which the maximum absorbance occurs is known as the lambda max. Beer-Lambert law is an equation used to find the absorbance of a solvent. The A in the equation stands for absorbance, which can be found using a spectrophotometer. Epsilon in the equation stands for molar absorptivity, which can be found and is distinguishable between solvents. L in the equation stands for the length of solution the light passes through, so the path length, and this can be found also by using the spectrophotometer and looking at the length of the wavelength. C stands for concentration, which can be found either by solving for the other variables or by having a known concentration. As you can see, absorbance and concentration have a linear relationship. Failing to zero the machine will cause the absorbance to be negative, which cannot happen because you cannot have a negative concentration. After completing the experiment and recording the data in your notebook, you must go back and clean your station. Wash and dry any containers and store cuvettes upside down. Take a wet paper towel and wipe the lab station. Thanks for watching.